Hello, everyone. So today we're going to go to a new chapter. This is chapter 10, Introducing Probabilities. So far we have finished sample and the population. We talked about the sampling process, and we talk about descriptive statistics. We describe a single variable using graph or numerical values. We describe relationship using graphs and, correlation. And we can also find the regression equation to describe the sample, the linear trend. So this part is done. So right now we're focusing on probability and distribution. And after that, we're going to do inferences. So this is the three clusters we have. Descriptive statistic, probability and distribution, this is a theory, and the inferences, this is the last cluster, working on probability distributions. So again, the symbols. So please get familiar with the symbols. Sample size, what symbol do we use? Small n, right? And population size, big N. Population standard deviation, sigma. Sample standard deviation, S. Population mean, mu. Sample mean, X bar. Standard normal variable, Z. Correlation, this is sample correlation, is R. And this is regression, sample regression. Slope is B1. Intercept is B0. And then probability observing a sample as extreme or more extreme, the sample collected in hypothesis test. So that's p-value. And then type 1 error rate is alpha. So p-value and alpha, they're both probability values being used in hypothesis test. By comparing them, we're making decisions, right? So learning objective of the chapter, we need to understand some term: random, probability, sample space, event, and distribution. To a lot of people, sample space is kind of confusing to them, even though, this is not a bad concept. I'm going to talk about it. Probability rules. So statistic is a study about probability. If you want to deal with probability, you need to follow probability rules. So this is very important. Make sure you remember all the rules and able to use them appropriately. And understand how to use density curve to describe the distribution of a continuous random variable. So here we're going to introduce a density curve. So please have a good understanding of the density curve. That way it will be a lot easier when we introduce normal distribution. All right, so we're gonna start with 4 terms: random, probability, sample space, and event. A random is talking about a process. So what kind of process is random? If you have a process that the outcome is uncertain, but you do know the distribution of the outcomes if you repeat that process many times. So the wording kind of a little awkward, but I can give you an example. So for example, if you toss a coin is a fair coin. It has, a head and has a tail, right? So then when you toss the coin, before the coin land, you're uncertain about what's going to happen. So it could fall on head, it could fall on tail, right? So we don't know what's going to happen. But if you repeat the tossing many times, if you toss the coin many times, you would expect to have the probability of getting head that will be 50%, and probability of getting a tail will be 50%, right? So you do know the distribution of the outcomes if you repeat it many times. So for those kind of process, we call it a random process, right? And then probability in statistics is defined as a ratio. So, for example, for tossing a coin, If you toss it many, many times, then probability of getting a head will be the number of times you observe the head divided by the total number of tosses you have, right? But this definition only happen if the number of rotation is very, very large. So when you toss the coin many, many times, then that ratio will be a probability. Okay. It's a very common term, random and probability. We use it all the time. So here we just add a little bit of flavor of the definition to it, but it's just our common sense term. There's nothing special. So here is another term, sample space, and this have some people getting struggle on this. The definition of the sample space is very simple. The set of all possible outcomes of a random process. So if you have a random process, then all the possible outcomes that could occur as a set is called a sample space. Right? So for example, if you toss a coin, we know the coin has head and tail, right? Then what is all the possible outcome after you toss it? You could get a head or a tail, right? So put them all together as a set. Head and tail is your sample space. Pretty simple, right? So some people get confused when asked the question in a different way. So we still have a coin. It still had a head and tail. And now we toss the coin. And then I'm going to define a variable as number of heads you observe after you toss the coin. So what's your sample space? So some people get confused. They're still saying head and tail, but that's not what that's not what the interest is, right? We want to record number of heads. So if you landed on head, what's the number of heads? 1, right? If you land on tail, what's the number of heads? 0, right? So in this case, sample space will be 0 and 1, right? All right, so think about it and let me know if you're still confused. I can give you a few more examples. And next term is event. Event is just a set of outcomes from the sample space. So we know sample space is a list of all the possible outcomes, right? If you take some of the outcomes as a smaller set, and that set is called an event. So event is always a subset of the sample space, right? So these 4 terms are related. Anytime when you talk about a probability, the probability is always going to be related to an event. So you're going to have some, a criteria set to get a subset of the sample space. So the probability is always about the probability of event. And the event is a subset of the sample space. And the sample space is defined from a random process, right? Okay. So then just, get familiar with some of the term here. When you toss a coin, record up face value, half face value will be either head or tail, right? So the sample space is head and tail. And the probability in the head is 50%. If you're rolling a die, the die has 6 faces with 1, 2, 3, 4, 5, and 6 on each side. And if you roll it and then just record up face number, and what's the sample space? Either 1 or 2 or 3 or 4 or 5 or 6, right? It's your sample space. What's probably getting 1? It's a fair die, so every face is equal likely, so it's 1/6. What's probability getting, up face greater than 4? Greater than 4, it will be, you have 2 possibilities, right? So 2 out of 6, right? Okay. So, this is an event, right? And this is an event, right? So anytime you talk about the probability, it's probability of particular event. Okay, pretty straightforward. Now, this is the first animal for attendance check. This is a seahorse. So we're dealing with probabilities, then we need to learn probability rules. You have to obey all the rules when you deal with probability. So we're going to talk about the 5 rules. Rule number 1, the probability of event A satisfies probability of event A is always going to be between 0 and 1. So basically, probability is a number between 0 and 1. The maximum you get for probability is 1. The minimum you get for probability is 0. There's no other probabilities, right? And that's common sense as well, right? When you say a probability, you're never going to say something that's more than 100%, right? Or a negative, right? Okay. So rule number 2, total probability of the entire sample space always equal to 1. So if you have a sample space defined, then the probability of the entire sample space equal to 1. So for example, if the sample space is head and tail, right? So probability of head or tail together is 1, right? So when you toss a coin, has to be a head or a tail, right? So probability of sample space equal to 1. It cannot be more, it cannot be less. And then rule number 3, we also call this rule as addition rule. So this rule will tell us when we can add probabilities together. The rule is very simple. Probability of A will equal, or B will equal to probability of A plus probability of B. Okay. So the key thing is when you have an or connecting A and B, the 2 individual events, then the probability of the complex event A or B will equal to probability of A add probability of B. So or is matching with addition. Okay. So here we have a term called disjoint. So you need to make sure you understand what the disjoint means. This rule doesn't always work. It only works if the condition is met, if the 2 events are disjoint. And what does disjoint means? Disjoint means they don't have any common outcome. Right? So for example, let's talk about rolling a die. So we can define different events. We can define event A as all even numbers. Then basically translate into 2, 4, and 6, right? That's event A. Event B as greater than 4. So then we know the sample space is 1, 2, 3, 4, 5, and 6. That was translated into either 5 or 6. And if we define event C as all odd numbers, so event C will be either 1 or 3 or 5. Then my question is, are A and B disjoint? Are A and C disjoint? Okay, so what does disjoint mean? Disjoint means the 2 events has no common outcome. They don't have anything in common, right? So when you look at A and B, you can see that 6 is a common outcome in there, right? So then A and B are not disjoint. Are A and C disjoint? A and C, there's nothing in common, right? So they are disjoint, right? So that's what the disjoint means. If the 2 events has no common outcome, then you can use the addition rule. Probability of A or B equal to probability of A plus probability of B. Right. So next rule is for any event A, probability A doesn't occur will equal to 1 minus probability of A. This rule is also called a complement rule, right? So probability of not A and probability of A will complement each other. They will add up to the whole sample space. So, this is a common sense as well, right? So for example, when you're betting, then probability of you winning a game will be 1 minus probability you're not winning the game, right? The probability of it's gonna rain tomorrow will be 1 minus probability it's not gonna rain tomorrow, right? So complement rule. And the next rule is also called a multiplication rule. So this rule will tell us when we can multiply probabilities together, okay? The rule is very simple, very similar to the addition rule, but here, if you have probability of A and B, that probability equal the probability of A multiplied by probability of B. So here, keyword is and match with multiplication, right? Or it's matching with addition, okay? So then this rule doesn't always work either. It only works if the condition is met, and the condition is called independent. If the two events A and B are independent, then we can use multiplication rule as probability of A and B equal to probability of A times probability of B. And what does independent means? Independent means the two events does not affect each other. So whatever happened to A is not going to affect B, and vice versa. So they're independent. So I'm going to use a small example to kind of illustrate a little bit on the independence, okay? So for example, if we're saying we have a bag and has 10 balls in it. Out of the 10 balls, we have 7 red balls and 3 black balls, okay? Then from the bag, we can define a scenario. So for example, in the first scenario, we're gonna take a ball randomly from the bag, and then we're gonna record a color. And after we record a color, we're gonna put it back into the bag. Then we're gonna take a second ball. And then record a color again. So this is a random process, right? For this random process, what will be the sample space? So when you talk about the sample space, you always need to think about what is being recorded, right? So in this case, we're recording 2 color of 2 balls, right? We were recording 2 color of the 2 balls we take, right? So what is one of the possible outcome? We could have first ball is red and second ball is red, right? We could have first ball is red, second ball is black. We could have first ball is black and second ball is red. We could have first ball is black and second ball is black, right? So that's our sample space. Okay, so then out of this sample space, it can define event. So if I define event A as the first ball is red, and I can define event B as the second ball is red. Okay, so if this is the case, what's probability of A? What's probability that the first ball you draw is a red color? So basically, when you take the first ball, how many balls are red out of how many balls are in the bag? And you can see it's 7 out of 10, right? You have 7 red balls out of 10 balls total in the bag. So probability of A equal to 7/10. What about probability of B equal to what? So when you take second ball, how many bars are in the bag and how many bars are red. You can see it's still 7 out of 10, right? So whether A is true or false, is that going to affect B? Second ball is, is red. Doesn't matter if A is red or not, the probability B will be 7 out of 10, right? So A doesn't affect B, right? So A and B are independent. All right, so now let's think about another scenario, okay? So we're gonna steal the same bag, has 10 balls, 7 red and 3 black. So now we're gonna take the first ball and then record the color. And now we're not gonna put it back anymore. It's gonna be put aside. Now we're gonna take a second ball and we're gonna record the color. Okay, this is a random process. So the sample space will be what? You're still recording 2 colors, right? So if you think about it, the sample space will stay the same, right? And now we define event A as the first ball is red. And then we can define event B as the second ball is red. It's the same event definition. And now let's see relationship A and B. What's probability of A? First ball is red. How likely is that? So when you take the first ball, how many balls are red? 7. How many balls are there total? 10, right? So 7 out of 10. Then what's probability of B now? So when you take the second ball, how many balls are in the bag? We have 9, right? Then how many balls are red out of the 9 balls left in the bag? Somebody may say it's 6. But someone else may say, hey, I don't think it's 6, it's 7, right? Which one is it? They're both possible, right? If A is true, if A is true, the first ball you take is a red ball, then there's gonna be 6 red balls left in the bag, right? But A is not always true. What if A is false? If the first ball you're taking out is black, then you're gonna have 7 red balls left in the bag, and you have 9 balls total, right? So you can see when A is true or false, it will affect B, right? So in this case, A affects B. So A and B are not independent. So this is what independent means, okay? Independent just means the 2 events that don't affect each other. Okay? And if that's the case, if the 2 events are independent, then probability of A and B, well, equal to probability of A times probability of B. Okay, so these are the 5 rules of the probability. A lot of times we use common sense to evaluate independence. So for example, if you randomly choose a student from, one class, and you randomly choose another student from a different class, is the first student gender being male or female affect the second student's gender? No, right? If that's the case, then the 2 events are independent. Or if you're rolling a die, rolling 2 dice, will the first die number affect the second die number? If it doesn't affect each other, then they're independent. So if you have a few computers in a computer lab, well, one computer, broke down, affect the other computer. If it doesn't, then they're independent, right? Okay. Right, so now we're gonna practice on using some of the probabilities to probability rules to find some probabilities of some complex events or some common sense common events, right? So suppose we have a die. A die has 6 faces, but we don't have number on the die anymore. It's a color, right? So it's 3 different colors on the dice. But for the 6 faces, 1 face is red, 2 faces are blue, and 3 faces are yellow, right? So you have 6 faces. Each of the 6 faces has the same chance to face up when you roll it. It's a fair die, right? Every face has the same chance to show. If one die is rolled and the variable x is up face color of the die, what is the sample space of x? What are the probability of each outcome in the sample space? So you only have 1 die, right? If you only have 1 die, you roll it, and you could just have the 3 different colors, right? Red or blue or yellow. So that's your sample space. Then what's probability of red? You have 1 face only, right? 1 out of 6. Probability of blue, 2 face blue out of 6 faces. Probability yellow, 3 yellow faces out of 6 faces, right? And the total probability is equal to 1, right? So this is just verification. The total probability for any sample space need to be equal to 1, right? This is pretty simple. You have 1 die, it's simple. What if we have 2 dice, right? They make it a little more complicated. So if your 2 dice are rolled and the variable x is the combination of the 2 dice color, what is the sample space of x? And what are the probability of each outcome in the sample space? All right, so I'm going to introduce a way to quickly find a sample space of any random process. If you are good at it, that's okay. If you struggle, here may be something you can do to make it easier. So for the problem here, if you have 2 dice and you roll them together and the sample space is you're going to record 2 colors, 1 color for each die, right? So basically you're going to have first die color and you're going to have second die color, right? So we know one possibility is red and red, right? Both die could be red. And then what is the sample space? Can you list all the possible outcome? So some people, some students are going to struggle on this. So there's a very systematic way to do this. So for example, if you just think about 1 die, it could have red, blue, or yellow, right? So then if you add another die, basically you just need a split. For first die being red, you think about what second die color will be. Second die could be red. Second die could be blue. Second die could be yellow, right? And then same deal, if the first die is blue, then what is the second die color could be? It could be red. It could be blue. And it could be yellow, right? And the same thing, if the first die is yellow, then the second die could be red. The second die could be blue. And second die could be yellow, right? So then you have your entire sample space listed, very, systematic. So if you want to have another die, just keep splitting. If the first 2 red If the first two die are red and red, what is the third die? Could be red, could be blue, could be yellow, right? You have another 3 splits, for each of the outcomes here. Okay. All right. Then the sample space is pretty easy to find. Now, how do I find the probability of each individual outcome in the sample space? So for example, what's probability of red and red? So here we need to use the probability rules we learned, right? So most commonly we need to use addition rule and multiplication rule. So the key thing is you need to identify what will be the connecting word in the complex event. Is it or is it and? Okay. So for example, when you say the sample space red, red, even though you write it in short like this, but what does it really mean? It means the first die is red and at the same time, the second die is red as well, right? So if that's the case, you have probability of A, you have B, you have A and B, right? And go back to the probability rule, A and B, we need to use multiplication rule, right? Just before you use the rule, check for the condition, independent. Will the first die being red or not affect the second die being red or not? They're independent, right? It doesn't affect each other. So then we can use multiplication rule. This would be probability of A times probability of B, right? So that's 1/6 times 1/6 is 1 out of 36. That's how you get it, probability here. And then probability of red and blue, for example. That will be probability of the first die is red and at the same time, second die is blue, right? Then is and connecting, so we need to use multiplication rule. So probably the first die is red times probability of second die is blue, right? So what's probably the first die is red? 1/6. You have 1 out of 6 faces as red, right? And what's probably the second die is blue? There'll be 2 out of 6, right? So then you multiply together. You don't have to simplify this. 2 out of 36, right? So that's red and blue, and so on. So red and yellow, 1/6 times 3/6, blue and red, 2/6 times 1/6, blue and blue, 2/6 times 2/6, right? And so on. And after you get all the probabilities calculated, verify by adding them up to see if they equal to 1. If the total doesn't add up to 1, that means some of the probability must have issues. There must be some incorrect probabilities, right? All right, so then we have more questions related. So we still have the 2 dice. What is the probability that exactly 1 die sells yellow? So exactly 1 die sells yellow. Then you need to think about this sample space. So which outcome has exactly 1 yellow dice, basically, right? So it could be this one. It could be this one, right? It could be this one. It could be this one, right? And that's it. So then probability of exactly 1 die is yellow will be red, yellow, blue, yellow, yellow, red, yellow, blue, right? That's the 4 remarked. But the thing is, you need to pay attention to, is it supposed to be or is it supposed to be and? So is it red, yellow, or blue, yellow, or red, yellow, and blue, yellow? So if you think about it, it should have been or, right? And when it's or, we use addition rule, right? So we're going to use addition rule for or. So then probability of exactly 1 die is yellow equal to probability of red yellow or blue yellow or yellow red or yellow blue. And for each of the outcome, We already find the probability in here. So we just find the corresponding probability. 336 plus 636 plus 336 plus 636 for yellow blue, right? So it's 18 out of 36. And what's the probability that less than 2 dice shows yellow? Less than 2. They have 2 dice. What is all the possible number of yellow dice? Less than 2 dice shows yellow. Basically, if you look at the whole sample space, the only outcome you don't count is yellow, yellow. This is 2 dice, right? It shows yellow. Everything else will be less than 2, right? So that event basically just not yellow, yellow. Everything else except yellow, yellow, right? So then probability of not A will equal to 1 minus probability of A. That's the complement rule we learned here, right? So then that'll be 1 minus probability of yellow, yellow. That's 27 out of 36. Okay. And next question, what's the probability the first die shows yellow and the second die doesn't show blue? So there are different ways of working this thing out. So one thing you can just, if you have the sample space already, you can just look at which one satisfies the outcome, right? So first die shows yellow. First die shows yellow has to be the last 3, right? First die is yellow. And then second die doesn't show blue. Second die cannot be blue, so it has to be yellow, red, or yellow, yellow, right? Yellow, red, or yellow, yellow. So then, since it's or, addition rule, right? So 336 and 936 add up together, that's 12 out of 36. But this is based on if you know this, distribution of this. But what if you don't know this? Then we have another way to very quickly to get a probability out. So probably the first die shows yellow and second die doesn't show blue. So you can see that we have 2 events connected by and, right? Then we know we can use multiplication rule. And they are independent. The first die color is not going to affect the second die color, right? So A doesn't affect B. We can use multiplication rule. So it'd be probably the first die shows yellow times probably the second die doesn't show blue. And then probably the second die doesn't show blue will be 1 minus probably second die shows blue, right? So there'll be 3, 6 for first die shows yellow, and 1 minus 2, 6 for second die doesn't show blue, and there'll be 12 out of 36 as well. So either way, you're gonna get the same answer. But this is preferred because it doesn't require you to know something as complicated as this, right? You can just figure it out by probability rule and the simple probability for a single dice. Right? So that's probability rules. It needs some practice to get used to it. So please spend some time on that. And now we have a new concept called a random variable. So what's a random variable? It's a variable that's it's a numerical outcome of a random phenomenon, a random process. So basically, if you define a numerical variable out of a random process, that variable is called a random variable. Since random variable will take more than one possible outcome, it's not going to be a fixed number anymore because it comes from random process, right? So it could have more than one possible outcome. So random variable will always have a distribution. The distribution will tell you exactly how likely the variable will take on each of the possible outcome in the sample space, right? So that's what distribution is. Since it's a numerical variable, and we learned in chapter 1, numerical variable has 2 different subsets. One is discrete, the other is continuous, right? So then that means the random variable will have 2 different types. One is discrete random variable, the other is continuous random variable. So then for the 2 different type of random variables, we have 2 different type of distributions. So we could have discrete distribution, we could have continuous distribution. And we describe the distribution of discrete and continuous in different format, okay? So for discrete random variable, we need to list the table, something like this, a table to list the individual outcome and probability, okay? And for continuous random variable, so instead of listing a table, we can't do it anymore because continuous variable has infinite number of outcomes always, because it could take any possible real number in a certain range, right? So there are infinite number of observations. You can't list infinite number of values in the table. So then we use a different approach. We use density curve to describe it. Okay, so we're going to talk about example of either case. All right, so first we're going to talk about the discrete random variable. So if we still talk about two dice we just used in the earlier example, but now I'm going to define a random variable x as number of dice showing yellow. So you're rolling two dice, and then we're going to define a variable x as number of yellow dice. What is the sample space of x? What are the probabilities of each outcome in the sample space? Right? So if you think about it, the sample space could be you have 0 yellow colors, right? If none of the dice shows yellow, then number of yellow dice equal to 0, right? And then you could have 1 yellow dice, and you could have 2 yellow dice, and that's all you have. That's your sample space, right? And then for each outcome in the sample space, we need to find the probability. So what's probability of 0? So we have 0 yellows. That means it could be red, red. It could be red, blue. It could be blue, red. It could be blue, blue, right? So red, red, or red, blue, or blue, red, or blue, blue. So we need to use addition rule. So we add all the probabilities up. There will be 9 out of 36. And the probability x to the 1 will be either red, yellow, or blue, yellow, or yellow, red, or yellow, blue, right? That has 1 yellow dice. So you add all the probabilities up, it's 18 out of 36. And probability x to the 2, it has to be yellow, yellow, right? That's the only outcome to give you 2 yellow dice. So then probability is 9 out of 36. So, you can find all the probability. So this is how you describe the distribution of a discrete random variable. So you make a table of it and list the sample space on one side and list the probability on the other side. That's the distribution of a discrete variable. Okay. So now let's talk about continuous random variable. So continuous variable will take all the possible real numbers, right? So for example, if you define a variable x as a number in a sample space between 0 and 1. So x will be any number between 0 and 1. And every number appear just once. Right? So then how are we going to describe the distribution? So here we're going to use something called a density curve. Okay. Density curve. Then how do I draw a density curve? Density curve has 2 axes. So you're going to draw x-axis here and y-axis here. X-axis is, the variable describing, that's just x. And the y-axis, actually, it's about probability of x. Okay, so the y is about the probability. Then we need to draw a density curve. A density curve is a curve on top of x-axis, right? So the sample space is between 0 and 1. So that means the curve has to be between 0 and 1. Then depending on the distribution, if you have a different distribution, the curve will be in different form. In this case, we have a condition. Every number appears just once, right? What does it indicate? That means every number has the same chance to occur. So since y is probability, that means we need to have a flat line, right? So every number has the same probability, right? So, but when you draw the flat line on y-axis, the line could be anywhere. You can draw it here, you can draw it here, you can draw it here, right? So where do we have to draw it so that this is a density curve? Okay, so this is related to something very important in density curve. We use area represent probability. Okay, so any probability in density curve is represented by an area. And then the sample space is x between 0 and 1, right? So probability of the sample space by the probability rules we learned earlier, the second rule of the probability, the probability of the sample space always need to equal to 1, right? So then if we go back to the density curve, the probability of the whole sample space need to equal to 1. But in density curve, probability of any event will be the area enclosed by the event between x-axis and density curve. So that means the shaded area need to equal to 1. The shaded area is probability of the sample space. That's by the definition of the density curve. Area represents the probability. Then what does the height have to be? So you have a rectangle shape, right? If the area equal to 1 and one side, the base equal to 1, what does the height have to be? So it's equal to 1, right? So height have to equal to 1 to make sure the total probability of the density curve equal to 1. Basically, the probability of the sample space equal to 1, right? Okay. So then once you find that height, then for any other event, you can find the probability very easily. So for example, if I ask you what's probability of x greater than 0.8, so you just need to find where 0.8 is at, right? If 0.8 is right here, then we know probability of x greater than 0.8 will be enclosing the area here, right? So then probability of this event will be the corresponding area. And this is area of a rectangle, right? It will be base times height. And what is base? Between 0.8 and 1, the distance is 0.2, right? And what is height? Height equal to 1, right? So that probability equal to 0.2. So very quickly you can find that probability. And likewise, what's probability of x is smaller than 0.3 or x is greater than 0.8. Okay, so you have or in here. Then we need to use a distance rule, right? So that'll be probability of x is smaller than 0.3 plus probability of x greater than 0.8. And then basically we have another area from 0.3 up, right? So then smaller than 0.3 will be 0.3 times 1 as the area. And then greater than 0.8 will be 0.8, will be 0.2, sorry, times 1. So the probability will be 0.5, right? So finding probability in the density curve for continuous distribution is just basically finding area. And then another thing, what's probability of x equal to 0.8? So what will be this probability? So 0.8 is right here. X equal to 0.8 is only this single line, right? What's the area enclosed by this single line by itself? 0, right? There's no area. Another way to find this event probability, x equal to 0.8 is, you think about, by the definition, how many times does 0.8 occur in the density curve, in the distribution? Only one time, right? Every number appears just once, right? Then how many possible numbers are there in a sample space? Infinity, right? And 1 divided by infinity is 0, right? Okay. So another practice. So what if you have a density curve shows the sample space between 0 and 2, and this also a flat density curve? What will be the height for this distribution? So basically, just like what we did earlier, the probability of the sample space has to equal to 1, right? And then the probability of the sample space will be the area shaded, right? Area represent the probability. And then for this rectangle shape, base equal to 2, area equal to 1. So what does height have to be? Base times height need to equal to 1, right? And base equal to 2, height will equal to 1/2, right? And what's probably the x greater than 1? Greater than 1 from 1 to the right, right? Then base times height. Base is 1, height is 1/2, right? So probably the x greater than 1 will equal to 1 times 1/2, right? Will equal to 1/2. And what's probably the x greater than or equal to 1? So when you include 1 or not, will that change anything for the probability? So this will be probably the x greater than 1 or x equal to 1, right? So when you have or, this is a distance rule. Then what's probably the x equal to 1? 0, right? A single point doesn't have probability. A single line doesn't have area, right? So this is still 1/2. I mean, we go through this trouble to figure it out, but you can just go ahead and say, hey, from 1 to 2, it doesn't matter if you include that 1 or not. It's always it's the same thing. It's just had the same area, right? And the probability x equal to 1 equal to 0, right? Okay. So then this summarizes today's lecture. So some important concepts, sample space, all the possible outcome of a random phenomenon. One thing need to pay attention is for the same random process, if you define different variables, then the sample space for that variable will be different. So sample space is not going to be the same for the same random process. It depended on what variable are you interested in. When you define different variable, you're going to have a different sample space, right? And the event is a set of the outcome. It's always a subset of the sample space. And of course, the 5 probability rules, you need to make sure you understand how to use them and, understand what it means. And then distributions. We have discrete and continuous variable. And so we have different type of distribution. So we have discrete distribution and we have continuous distribution. For continuous distribution, we use density curve to describe the distribution. And in density curve, we use area represent the probability. So in our case, we talked about a uniform distribution. This is what it's called. So uniform means every number in the sample space has a uniform probability to occur, right? So in some distributions, the probability doesn't have the same chance to occur anymore. So the density curve will not be a flat line anymore. So it could be, some curved lines, right? So this number has higher probability than this number. The probability is higher, right? It's not probably being all the same. And then the most important distribution in statistics has a density curve look like this. And some people already seen a density curve like this, right? This is normal distribution. And this is the most important distribution, right? So then when you try to find the probability in normal distribution, it's the same deal. When you try to find the probability in of an event, for example, is x is less than 100, right? Then you just need to find area. But the only problem is if you try to find an area in the rectangular shape, you can just use base times height. It's a regular shape, right? But this is a curved shape. There's no formula to calculate this area anymore. So we're going to use a table to look it up. And that table is called a Z table. Okay. So we're going to have a Z table once we talk about the normal distribution. Right. So then this concludes today's lecture. There's another practice. This is very similar to the one we did on the dice. So, think about this. And if you have any questions, you can let me know. And we can work on this during office hours, or we can communicate through email. Right? So send me any questions. Thank you.